Okay, rational functions, example 6. F of x is x cubed plus 3x squared over 9x minus x cubed. And we want divide. Usually it'll be helpful to do long division in order to get the asymptotes. So we want to divide the numerator into the denominator rather into the numerator. And I usually like to list the highest power of x first. So I'm going to list the denominator as negative x cubed plus 9x minus x cubed plus 9x, and we want to divide that into x cubed plus 3x squared. Okay, so we divide the highest power of x by the highest power of x. X cubed divide by negative x cubed is negative 1, and then multiply. Negative 1 times negative x cubed is x cubed. Negative 1 times 9x is negative 9x. Draw the line, change the signs, add or subtract like terms according to the sign. There's no x squared term down here, so we just bring this down. 3x squared plus 0 is 3x squared. And there's no x to the first power in the dividend here. 0 plus 9x is positive 9x. So this is our remainder is 3x squared plus 9x. Our degree of our remainder is less than the degree of our divisor, so so that we can stop there. This will be plus 3x squared plus 9x over negative x cubed plus 9x. Okay, so the horizontal asymptote is going to be y equal negative 1. So this is the horizontal asymptote here. Maybe I'll do a different color. This is the horizontal asymptote. It's y equal negative 1. And then we want to factor the numerator to get the other asymptotes. So this is f of x is going to be 1 plus 3x squared plus 9x over negative x cubed plus 9x. And then in the numerator we have a common factor of 3x. 3 goes into both terms. There's also an x in both terms. So we'll factor that out. Divide each term by 3x. 3x squared divided by 3x is just going to be x. And 9x divided by 3x is 3. The x's will cancel. And the numerator, our denominator, we have a common factor of negative x. And if we divide, we'll have x squared minus 9 is what's going to be left over. And then we can break this down further. This what's called a difference of squares. We can add and subtract the square roots. So this is going to be negative 9 plus 3x, x plus 3 over negative x, and this will factor into x plus 3 times x minus 3. Okay, so okay, so then we can cancel. We can reduce this fraction now. We have an x plus 3 on top and bottom. We have x on top and bottom. Positive divided by negative is negative. So this is going to be equals negative 1 minus 3 over x minus 3. Okay. Okay, so so x cannot be, before we reduced, we had some factors in the denominator, and the denominator cannot be 0, so x cannot be 0, and x cannot be negative 3, and also x cannot equal positive 3. So so those are our restrictions, and these this one is an asymptote. It's a vertical asymptote, and these are holes. Okay, so because so the asymptote, the vertical asymptotes occur wherever, for any number that makes the denominator of the reduced fraction equal to 0. The holes occur if they make the unreduced fraction, denominator of the unreduced fraction equal to 0. So these two are holes. They're they make the denominator of the unreduced fraction equal to 0, but they don't occur in the denominator of the reduced fraction. So we have horizontal asymptote, y equal -1, vertical asymptote, x equal 3, and two holes, x equals 0, x equal -3. So this is basically a hyperbola with two holes in it. If you have a rational function, or fractional function, rational function with exactly one vertical asymptote and one other asymptote, the shape of the graph is going to be a hyperbola, but this one will be a hyperbola with two holes in it. So now we can plot some points and sketch the graph. Let's plot some points and sketch the graph here. So the so our formula, our reduced fraction is f of x equals -1 minus 3 over x minus 3. Okay. So we want to plot some points on either side of the vertical asymptote, and we'll also include the holes. Well, let's start at -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, 5. Okay, so if x is -4, we'll have -1 minus 3 over -4 minus 3 is -7. So it's -1 plus 3/7. -7 over 7 plus 3 over 7, -4/7. If x is -3, we'll have -1 minus 3 over -3 minus 3, -1 minus 3 over -6. Double negative is positive. It's -1 plus 3/6, -1 plus a half, -1/2. But this one is a hole, so you have to keep in mind when we draw the graph, it's actually going to be a hole. And then x is -2. We have -1 minus 3 over -2 minus 3, -1 minus 3 over -5. -1 plus 3/5. That's going to be -2/5. Back is -1. -1 minus 3 over -1 minus 3. -1 minus 3 over -4. -1 plus 3/4. and that's going to be negative 1/4. Okay. X is 0. This is going to be another whole. And this is going to be minus 1 minus 3 over 0 minus 3. That's 1 minus 3 over negative 3. Negative 1 plus 1 is 0. If x is 1, we'll have negative 1 minus 3 over 1 minus 3. Negative 1 minus 3 over negative 2. Negative 1 plus 3 halves, 1 half. And if x is 2, negative 1 minus 3 over 2 minus 3. Negative 1 minus 3 over negative 1. Negative 1 plus 3 is 2. If x is 3, that's going to be our asymptote. It's going to be undefined there. We have put in 3, you get denominator 0. If x is 4, negative 1 minus 3 over 4 minus 3. Negative 1 minus 3 over 1. That's going to be negative 4. If x is 5, negative 1 minus 3 over 5 minus 3. Negative 1 minus 3 over 2 would be negative 5 halves, negative 2 1/2. Okay, so so then we can plot the points and draw the graph. So let's see. Okay, so we're drawing a coordinate system. The horizontal scale is for x, the vertical scale is for f of x. We want a horizontal asymptote at y equal negative 1. So that's going to be, we put a dotted line for the asymptote there, and we'll have a vertical asymptote at x equals 3. Put a dotted line there, and then we can plot the points. So it's negative 4, it's down 4, and down negative 4/7. It's a little bit less than negative 1/2. So it's 4 to the left, and down 4/7. And then we have 3 to the left, down 1/2, and 2 to the left, down 2/5. It's a little less than 1/2. 1 to the left, down 1/4. 0 0. 0 0 is a whole. Yeah, I forgot. Should have made that a whole. And also negative 3, 4/7. Negative 3, negative 1/2. That's a whole. Okay, so those are two wholes. And then 1 to the right, up 1/2. 2 to the right, up 2, and 3 is undefined. That's where a vertical asymptote is. So we want to connect the dots and extend it toward the asymptotes, and so that's our one piece of our hyperbola. And we have the two holes there where it's undefined, but there's no asymptote at the holes. And then other points, we have 1 to the right, we have 4 to the right, up, down 4, 4 to the right, down 4, and 5 to the right, down 2 1/2, and connect the dots, extend it toward the asymptote. So that's the other branch of our hyperbola. So that's our graph. So okay, so at the hyperbola, we have vertical asymptote, horizontal asymptote, and we have two holes, the domain negative infinity to negative 3, union negative 3 to 0, union 0 to 3, union 3 to infinity. So we have little gaps here for the two holes there and the vertical asymptote. And the range, well, we'll have a gap in the range at negative 1. That's the horizontal asymptote. So the range is minus infinity to negative 1, union negative 1 to infinity. And that concludes this presentation.